Good afternoon, everyone. Today we are going to see how to go about performing logistic regression using R. Okay. Before that, and continuation with our last session where we saw what is a modeling base, what is a target variable, what are observation window, what is a prediction window, all the basics of model development. And then we saw why logistic regression is required. We already have a linear regression. In linear regression, we are trying to establish a relationship between independent variable y, sorry, we are trying to establish a relationship between a dependent variable y and series of independent variable. There are scenarios where our target is either 1 or 0. We have got a data, and the data that we are using is from a banking space where the bank has executed a campaign. Some customers responded to that campaign and they took the offer. Those were marked as 1, and some customers did not take the offer and they were marked as 0. And then we are trying to build a logistic regression on that data set. Just let me quickly run some code to show you what is the data set that we are running, and then I'll ask you to execute those codes. So this is the data that I have shared with you, where there are certain demographics parameter like age, gender, occupation, and there are certain behavioral parameters like balance, number of credit transactions, score, holding period. And the customers who have taken the offer based on campaign are marked as 1, and those who did not take the offer are marked as 0. All the behavioral variables are taken from a observation window. That is, before the campaign was executed, the behavioral variables and the static demographic variables, all of them come from a point in time which is just before the execution of the campaign. When I say just before, it means either 1 month before or 3 months before or 6 months before. And that target variable 1 or 0 is defined based on whether the customer took the offer in the campaign period when the offer was running. Okay. Now this data looks like this. This is the format. Now one of the questions that I felt many people don't understand is how is probability coming into play in this entire picture when we are building the model. So first what I'm going to do is try to explain how this concept of probability is coming into play. Okay. Let me close this data set. And so this one is the icon. Let me close the data set. Let me run a few commands. What I'm going to do is I'm going to use a package R pivot table. So I load the package. The R pivot table is already installed in my machine. Just in case it is not installed with in your machine, then you have to run this command. This install step should help you load the package. Because it is already there in my machine, I'll just comment it out. So library, when I run the library syntax, the package gets loaded, and there is this data frame is already available in my machine. So I'm going to use R pivot table LRDF. The moment I run this, you can see that a pivot table kind of a structure opens in my browser window. So here what I'll do is I'll drop the target, and let me now take one of the dimension, one of the predictor variable, X target is our Y in this case. And gender, balance, occupation, number of credit transactions, age bucket, score, holding period, age, all these variables are our independent variables by which we are want to try to predict who is going to be a responder and who is not going to be a non-responder. So let me take one of the variables, say age. I drop age here and let me use this pivot table features. I want count as a fraction of rows. Okay. So when I'm doing this pivot table, so basically what I'm trying to do is I'm trying to do some diagnosis. The campaign was sent to customers in all age groups between, here you can see that 21 is the age, lowest age, and 55 is the highest age. Yeah. So we can see that the campaign was executed to all customers who are in the age group 21 to 55. Okay. Let me put count instead of count as a fraction. What it shows me, of the total base, which is 20,000 in our case, 212 customers were from the age group 21, 248 were from the age group 22, 384 from 23, and so forth. I can have these numbers for all the age buckets. Yeah. Of this 212, 5 customers actually responded. Rest of them did not respond. Of this 248, 7 responded and rest 241 did not respond. The one is saying the responders, right? Zeros are basically who did not respond to our offer and you did not take the offer. This number now I am showing in a row proportion. Count as fraction of rows. So what it is showing you, in age bucket 21, 2.4% of the customers responded. Can I express this 2.4 in probability terms? I can. If I express it in probability terms, it would be 2.4 divided by 100. Okay, so it will be 0.024. Yeah. So 0.024 proportion of customers responded in age bucket 21. Can I make that statement? Let me make the statements all in percentage. So in 22 age group, 2.8% responded. So I can see that from as I move the age 21, 22, 23, 24, there is a slight blip, and then 24, then there is it keeps increasing. 28, 29, there is an increase. 25, 29, and so forth. 53. Let me try to see if I can make a line plot of it. Line chart. Line chart count as a proportion. What are these things showing? Many red colors. I want to show not a line. Let me put a stacked bar chart. And this axis, this should be my x-axis, age, and this one should be count. No, I'm not able to show a stacked bar. So let me go back to my old chart only, table, and count as a fraction of rows. So here I can see that this percentage keeps increasing. Sorry, this percentage keeps increasing, and in different age buckets there are different percentage of responders and non-responders. Let us take another category now. Instead of age, let me take something else, occupation. Now when I see occupation, what I am seeing that There are 5 categories in occupation. One of the category is missing. In that 4.5% of the customers have taken the offer. There is second category which is professional. There is a 4%, salaried 2.7, self-employed 8.9 and self-employed non-professional only 1.4. So now when I see these numbers, I can see that in the overall base, when I targeted 20,000 customers, 4.4% of them responded, which means that out of every 100, 4.4% of them are responding. But if I see it segment wise, I see that self-employed segment, the response rate is as high as 8.9%, whereas self-employed non-professional, the response is just 1.4%. Yeah, so I saw one dimension which is age. I saw a second dimension which is occupation. Now let me see, but now can you see how this 1 and 0, this is 0 and this is 1, how this 1 and 0 information, when I aggregate over segment level, that numbers are giving me probabilities. Are you getting the point? At the individual level, it is 1 or 0. But when I aggregate all customers who belong to self-employed category, it gives me what proportion of self-employed responded. When I aggregate things at salaried level, it gives me what proportion of salaried responded. Now can you see that when you aggregate these ones and zeros, the probability comes into play. Yeah. Let us take this forward. Instead of taking occupation, let me take a continuous variable holding period. Now when I see holding period, so there is 0, 4.2, 12, 10, for the 12, 10, 8, 7, 7, 7, 6, 6, 5, and here you can see that as my holding period is increasing, this proportion of customers who respond is decreasing. Yeah, except for there is a null category where there is a 3.5, and except that and 0 where there is aberration, because 12, 10 and so forth, but then here at 0 there is a 4.2, which means there is some reason, some data thing that we need to handle. But the point I'm trying to make is, again I can see that if I segment the data based on holding period and I aggregate zeros and ones and see what proportion of in customers in that segment responded, again probability comes into play. Yeah. Likewise, I can do this for other variables also. Yeah. So there is some trend here. As my transaction is increasing, I see that proportion is increasing. So it starts from 1.5, 0.9, 1.3, 1.7, 2.3, 3, 4, 4.9, and then as you keep increasing, you see there are here the segments have higher probability, have higher proportions of customers responding compared to here. Now all these are trends, but these trends, what is happening is we are seeing them in a one dimension. Basically each time when I'm seeing this, I'm seeing one variable. I'm just seeing one variable and getting the trend. If we were to just see one dimension, what we can do best? What best we can do is, probably we may say, okay, I don't want to see things in one dimension only. I want to see things in two dimension. Probably let me take two dimensions. I'll take a gender here, say age bucket, and here when I see zeros and ones. Okay. So here I can again get proportions in this cell. What proportions are now coming, I don't know, but I can now compute a crosstab between target, basically I can do a cross tab between age bucket and occupation and see what proportion of customers who are in 26 to 30, okay, are in this cell zeros and are in this cell. Let me put this here. Does it make a difference? 18. Wait. Count as a proportion of columns. No, 24, and this number should actually add up to 100. So it will say in 26 to 30 missing occupation, what proportion of zeros are there and what proportion of ones are there. The point I am trying to make is, from one dimension you can go max 2 dimension and then start visualizing things. From one dimension I can make a cross tab and start seeing things in a 2-dimension perspective. This is a cross tab. Okay, what I wanted to do was, rather than getting these numbers like this, I'll just show you. If this thing I would have done, let me take smaller dimensions because that becomes easy. Okay, if I copy this cell, copy it in Excel. I'm pasted the entire table in Excel now. What this Excel says, this is a missing occupation category. Yeah. In this missing Excel, occupation missing and female. If I see the interaction, these many zeros are there, this many ones are there. So what I can do is, I can have a similar structure coming parallelly down and now merge them. Okay. And then I can say, in this intersection, .86% of customers whose occupation is missing and are female, that much percentage of customers are responding. What did I do? I took a ratio of 19, which is intersection of this, the yellow colored. Okay. And I'm now concerned about these two numbers, which I am increasing the font size. These two numbers. I did a ratio of occupation missing and gender female, and then I'm saying 19 divided by 2182 plus 19, that is 0.86 percentage, which is, if someone occupation is missing and gender is female, in that segment 0.86 percentage of customers are likely to respond. What this means is, if I target 100 such customers from my database where occupation is missing and gender is female, then out of 100, one is going to respond to my offer. Yeah. Likewise, I can do the same calculation across. Here, what it shows is, if I do that same thing where missing and gender male, then the response can be 7.75. Let us put this formula across. So here, when I see that, it gives me segments. This is a nice segment to target. This is a nice segment to target because my response rates are good here. Basically, I get more success. This is a good segment. And these are good segments where I should be targeting because I get a response which is higher than the average. Average was 4.4 something. How do I know what is the average? I know if I remove all of them, say occupation, gender, count as a fraction of rows. It is 4.4. Of the total data, I have 4.4% are responders. When I see 2 dimensions, I can see that. Now if I want to go in 3 dimensions, what do I do? See, as a normal human being, we can visualize things in a 1 dimension. Yeah, the 1 dimension is what I showed you like this here. Yeah, so I can see overall response rate is 4.4, but in male relatively there is higher response. Instead of gender, if I take occupation, this is what we did, and here we saw that 8.9 percentage. Yeah, so from 1 dimension I move to 2 dimension. From 2 dimension I can still move to 3 dimension also, make some complicated cross tabs and go to 3 dimension and try to interpret numbers. But how do I go to n dimension? How do I see the interplay? How do I see the interplay between n dimensions such that I can get these segments, these better segments, where I get a relatively better response rate? Technically, I can make a classification tree kind of a structure, a tree-like structure. I'll say first I'll split the entire data by occupation. Then I'll split it by age bucket, and then within occupation buckets I'll split it by age bucket. Then I'll split it by say balance, by holding period, and so forth. If that kind of a modeling technique we use, it is called classification tree technique. The other way is basically regression techniques. The other techniques are basically regression techniques, and this is one challenge which we can solve using a technique like logistic regression, which is a multivariate analysis wherein multiple dimensions and the interplay between those multiple dimensions will be taken into account, and we will get one equation such that when we score each customer using that equation, we will get a measure of probability for each customer. Is there any questions at this point of time? Because if this is not clear, then there's no point I proceeding and explaining the entire logistic regression. As we took this occupation from a 1 dimension, when we said self-employed has got 8.9% probability, as I took it from a 1 dimension perspective to a 2 dimension perspective, which is I've shown here, where I'm now taking self-employed with respect to gender. And then I see this cross tab, basically this one. If I see here 8.9% is there, but here 9.8 and 12.5. Can you see this 9 point? Let me change the color. Let me make it more darker, and in this segment, this is again for self-employed only. But when I split the self-employed by a second dimension, which is gender, I see within self-employed someone whose gender is others. Basically, probably they already have an account which is a current account. In current account, many times it comes as others. It will not be male, female. So self-employed who already have a current account which is not proprietorship, which is like a corporate kind of thing, you get this. And self-employed who are male, these two segments are relatively having higher response propensity compared to females, which means from a response rate which was just 4.4, if I say I cannot target everyone due to financial constraints and resource constraints, I want to target only a fraction of the base. In that case, that fraction would be self-employed. Now, if there is further constraint, I cannot target the whole thing, then probably I will say this is a better one. Yeah, that is one. Now, if I say, but I want slightly more base to target, what I can see, even self-employed female is low propensity compared to missing male, which means just going by self-employed and then targeting all may not be a right idea. Going by self-employed male and others would be the best one. If I have still further resources to target, then I should go in missing male category. That would have made more sense than going in self-employed female. So what is happening is when I start moving from a one dimension perspective to a two dimension perspective, I get finer segments. Is it possible that this 9.8 and 12, can I get further segments where probably my response rate is 18%, 20%? Can I get those segments also? It is quite possible that I can get segments where I could get 18 and 20% response rates also. If I go from a 2-dimension to 3-dimension, or probably if I go from a 3-dimension to 4-dimension, which means if I can build something where n dimensions can come together, the interplay between this, now there is an interplay between 2 dimensions. Crosstab is basically 2 dimensions. And with 2 dimension, I'm seeing target. If I can build something where there is an interplay between n dimensions with respect to target, and I can have a business rule or an equation, I can get finer propensities at those granular segments and then say these segments are better and these segments are not better. And that is what we are doing in a logistic regression. That is what we are doing in a logistic regression.
So what we derive out of this is a predictive model on bias and variance. We mentioned about that concept, right?
Yes, what we are now going to end up is build a predictive model which will take into factor many of these dimensions and give us an equation. And once the model is built, we can use that model to score and predict propensity for any customer to respond to the offer for which this model has been built. Yeah? If this concept is clear, I can move forward to logistic regression model development. Yokesh, can we move forward?
Yes, sir. Yeah.
Okay, great. So let's move forward to logistic regression. When in our earlier session, we already saw the relationship in logistic regression. If I directly build the model for probability with respect to the independent variables, the problem is probability range is between 0 and 1. But if I build a model directly with respect to probability as my y variable, in that case, I can have values which is less than 0 or I can have values which is greater than 1. Because in a linear equation, values are not bounded between 0 and 1. So we saw that logistic regression is like a modification of a linear regression where y that we are for which we are building the model, that y is actually ln log of odds. What is odds? Odds is probability of event occurring minus probability of event not occurring. That is log odds. And this is what we are building in a logistic regression. And then we solve this. If I take this log component from left hand side to the right hand side, this will become p 1 upon minus p is equal to exponential y. if I take this 1 minus p on the right hand side, it will become p 1 minus p star exponential y. If I solve this and take this component on the left hand side, I make p common. This is what I get. I take this in denominator. I get p is equal to exponential y upon 1 plus exponential y. That is 1 upon 1 plus exponential e raised to exponential of minus y. What is that minus y? That is a plus b dot x plus b2, b1 x1, b2 x2 and so forth. That's what we saw in our last session. We also understood this mathematical constant, natural logarithmic logistic regression equation. Now let's start with building the logistic regression model in R. Yeah. The first step is basically we have to go about importing the data, creating the data for building the model. What I have done is I have already sent you a data file which is at this level. After having done all the steps from the previous slide, it is at this level where we have got logistic regression data frame. So what I want you people to do, can you set your working directory path? The file lrdf.r data file which I sent you in email today, download that file, put it in some appropriate folder. Once you have downloaded the file and you have put it in an appropriate file folder path, set the folder path to the set the folder path using setwd to the folder in which you have kept that R data file, lrdf.rdata. Okay, so the file lrdf.rdata for me is in this working folder which is K2 analytics data file temp out. So I'm setting my working directory. Using the load command, I'm loading the file. This is a prepared data set that I have given to you people, and having loaded it, I'm doing a view. Just the same data set on which we currently worked and created the pivot table, all the steps. This is the same data set. Okay. In this data set, let us do a quick business understanding and a data understanding. I have already mentioned that this data is a data from a banking domain where some campaign was executed by the bank in past to sell a personal loan. The offer went on for a 1 month period. The static demographics demographics and the behavioral variables are at the point before executing the campaign, and the target variable is based upon customers who responded to the offer during the campaign period. Okay, those who responded, those customers are marked as 1. Those who did not respond are marked as 0. The demographics variable available is age, gender, occupation. The behavioral variables that is available is balance, number of credit transactions, score, holding period. Okay. So these are the variables with which we are going to play around. Before I go more in detail about this, let us understand some business part of this. Assume you have to sell personal loan to your customers. You are in a bank. You are working in a bank and you wish to sell personal loans to customer. Irrespective of the variables which I have mentioned here, think aloud. Think what behavioral attributes of the customer you are going to see to identify whether a customer would require a loan or not require a loan. Put yourself as a customer. think, if I need a loan, personal loan, why I need a personal loan? If I don't need a personal loan, why I don't need a personal loan? Can you start thinking of some variables and let me know?
One of the things can be like you go to the bank website and you have some link just asking you or mentioning something that are you looking for a loan with less interest. If you're interested, you will definitely click on that and see. That can be tracked in the system. If this person has visited this page, how frequently he has visited or how many times he visited. So this is one of the behavior on the website. Just a behavior.
Okay.
Another thing is
So
like
one of the point which is coming from candidates who are sitting in classroom is, if I can track the website behavior of a customer who is on my portal, on my net banking page, and if I see which page links he is clicking, and if I see that he's going into my loan section, and within loan section, specifically if he is going into personal loan section, but he's still not applying, but if I can check the URLs, I can come to know which of my customers are looking for loan. Very good point. Yeah, continue.
Another thing can be if we can see, if we can track the balance and we can see that the credit happening to the account is less but of huge volume and his is having very less balance left at the end of the month. So that can one of the implications that he is looking for a loan. He may not apply due to interest constraints or which
Yeah.
is what a normal salary guy will think that
Yeah.
it's interest.
So second point that is coming up is, if someone is withdrawing good amount of money from his account, but the amount that is coming into the account is less compared to what is going out of the account, as a result of which the average monthly balance or average quarterly balance drops down, that can be indicator that the customer is looking for a loan or may be in need of a loan. Similar hypothesis, can you create more hypothesis? Online people also. So because that's what analytics is all about. Analytics is all about thinking these hypotheses and then creating these variables. Analytics is not just about running a logistic regression technique. Because end of day, you're running a logistic regression technique using some independent variables, and those independent variables are independent variables that you create based upon your hypothesis.
Similarly, this can be an option. Current account holder, like his monthly expenses, his expiry date, and that figure is not being shown in the balance. Maybe this can be an option he can be looking out for.
So the third point is basically current account customers who are running proprietorship business or their own business. If the expenses or the outgoes is higher compared to the income level or the inflows in the account, is an indicator that to make ends meet, because end of day they have to make their salaries and other expenses, they have to keep doing that. So they may require a loan, they may require a short-term loan, gap funding, and whatever you call it, working capital, but they may require a loan. Yeah.
Again, not a personal loan, maybe a car loan. Like if the person is visiting some of the pages,
Yeah.
as in like for some kind of thing.
Yeah.
So like he can be influenced to take a loan.
Sure. So basically a person visiting loan pages, car loan, home loan, whatever pages, so again that can be an indicator. So these kind of hypothesis is what we have to keep developing. And these hypotheses are basically attributes. Okay. These are basically your independent variables. And then what we are doing in logistic regression, we are regressing these independent variables with respect to our target, and then trying to see which hypothesis is fitting well and which of these hypotheses are becoming finally part of the model. That is what regression process is all about. If at the macro level, at the top business concept level, if you understand this, then logistic regression is just a way of running your steps and building the model. Okay, so now let's see what are the various steps. So we already have a data frame, and now here are certain variables that I have given. Let me explain the hypothesis for these variables that probably I may have. For example, age. Too young a person may probably not need a loan. Too old may not need a loan. Middle age is a segment where people may require a loan. So my hypothesis would be middle age customers are more likely to take personal loan as compared to youth or old age. Gender. Males are more likely to take loans compared to females. These kind of statements are hypothesis. Balance. Customers having low balance in the account are more likely to need a personal loan compared to those who have high balance in the account. For example, I call up a customer whose average quarterly balance is 3 lakh rupee. And then I call the customer, sir, we are offering a personal loan of 2.5 lakh rupees at a very attractive interest rate of 10%. The customer may probably not want it because he would feel that when I already have that much of money in account and on which I get only a 4% interest on a savings account, if I take a loan, I'll end up paying 10% interest rate. What is the point of taking that loan? Are you getting? So that can be hypothesis. Occupation. Salaried people have a fixed inflow. Self-employed have got a variable inflow. Now, sometimes they may require more money, sometimes they may require less money. As such, they may require some kind of a loan. Self-employed are more likely to go for a loan because they are risk takers compared to salaried. So the hypothesis is that salaried requires less likely to go for personal loan as compared to self-employed. Number of credit transactions. Now, if I want a loan, I'll go to a bank where my relationship is strong, because I know if my relationship is strong, then probably I can quickly get my documentation done and easily get the documentation done. So, and how do I know which bank my relationship is strong or for which customer I am the primary bank? If I see their amount of transactions, number of transactions, if there are more transactions, the customer is more involved with the bank. If the customer is more involved with the bank, if there is need of any product or service, his first choice will be that bank only. So those customers who have got high frequency of transaction, high volume of transactions are more likely to take a loan from me as compared to those customers who have got less frequency of transaction. This is again a hypothesis. Score. This score can be a credit score or it can be a marketing score. If it's a credit score, based on credit score, those customers who are more risky are more likely to take a loan. Though bank may not give them a loan, that is a different story. But here my objective is marketing. Who is going to take loan and who is not going to take loan? So I'm not going to bother of risk at this point of time. If I'm bothered of risk model will take care of. When I'm building a marketing model has to take the marketing variables. So a customer who is more risky will take more risk, more loan. So poor credit score customers are more likely to take loans. Holding period. I have already informed what is holding period. Let me explain this again. Holding period is a measure of customers' ability to retain money in the account. For example, there is two customers. One customer get 1 lakh rupee as salary. Assume beginning of the month there is 0 rupees in the account. On first of the month he gets 1 lakh rupee credited. By second of the month the entire 1 lakh money is out of the account because of various EMI payments, utility bill payments, credit card payments and so forth. AQB of this customer, average monthly balance of this customer will be 1 lakh into 1 day divided by number of days in the month. Assume 30. Now let's consider the another customer. He gets at the beginning of month there is 0 rupees. On first he gets a salary of 10,000 rupees. After 10 days, entire money goes out of the account. If I see the average monthly balance of this customer, average monthly balance of this customer will be 10,000 multiplied 10 divided by number of days in month. We assume 30, so it will be 1 lakh divided by 30. This customer's average monthly balance and the previous customer's average monthly balance is same. But who has kept money for longer duration? The second guy. Second guy has been able to hold money longer, which means he is less need of money compared to someone who is not able to hold money. So low holding period will indicate higher need for loan and high holding period will indicate lower need for loan. Yeah. So these are hypotheses. And based as you make these hypotheses, you create variables. Yeah. So these are the variables and the corresponding hypothesis I have explained for each of the variables. Yeah. Okay. We have seen the data set also. Now the first step is once you know your business understanding and now you have at a high level conceptually you have understood I want to build a model to cross-sell personal loans and I have created certain variables based upon that. First thing is you should do a understanding of how the distribution of every variables are. To do a quick distribution of how the variables are, you can run a simple function called summary. Okay, so let us quickly run the summary function. So here is my data set. I'll skip all these steps because I have given you a prepared data set. Don't bother about it. Yeah, come to somewhere where I have typed summary lr underscore df. Control R. The moment I run this summary function, it gives me a quick summary of the entire data. So let us try to understand each and every aspect of it. So first what I see, customer ID. It says C11, C10, C100, and then others 19,994. What it clearly shows me that customer ID is my unique identifier. Yeah. Then target. Obviously the min value of target will be 0. Max value will be 1. Yeah. Because a customer who responded is marked as 1 and those who have not responded are marked as 0. Age.
So I have a question.
Yeah.
Normally in
The question that is being asked is, in real life, how do you get the value of target? Assume I'm a
or
bank.
any continuous variable also, let's say, I mean, for example, let's say sales or anything. So how do we usually get that?
Let's understand the target. I'm a bank and my bank's name is my bank. I am in the business and so far I have not been doing analytics. So far I have not been doing analytics. And I have got branches, my ATMs, my internet, network, all these things are there. So customer comes in, they say, sir, I want loan. They fill the form, I give it. I've got a feet on street, I've got direct selling agents, I've got internet. So I get leads and then I keep closing those leads. And then someone comes to me and says that, gives me this consulting knowledge saying that you can better your sales if you can use predictive analytics. Then what he would suggest is, to do predictive analytics, we have to build these models. So probably one of the suggestions the consultant would say is that because you are not doing active campaigning, so now let us do one campaign. From the entire data, there will be certain risk filters which are bare minimum that has to be applied. Some bare minimum filters is like, I cannot give loan to anyone who is less than 18. I cannot give loan to someone who is retired, right? So I'll apply those filters. I cannot give loan to customer whose account is not been operated for last 3 or 6 months. Inactive accounts, dormant accounts, I cannot give loans. So those bare minimum filters will be applied, and I'll get a data set who satisfy those criteria. Now if that data is available, can I design an offer and send a campaign to them? I design the offer and send a campaign. Say I send a campaign in the month of April. Now I have gone to my bank and I've done this all consultancy. They give me the contract. In March, I'll do all this thing. Based upon their internal policies, I'll apply the filters, get the data, and execute a campaign. All the data which I use for applying filters will be before end of March, because the campaign I am running on April. I'll run the campaign. I'll send email, SMS. If direct mailers have to be couriered, I'll do all of those. Which means there is some communication about the offer to the customer. Some of these customers are going to come, take the offer. Say, assume I say the offer of low interest rate is allowed only if you give the offer code. Like Uber, Ola, they give you offer code only, then you get the offer discount, right? So I say you get a preferential rate only if you give me the offer code, by which I will know who is responding to the campaign offer. Yeah. So in April, those customers will come and take the loan. By 30th of April, all customers who wanted loan will take, who did not wish, they may not take. I'll take a cutoff of 30th. On 1st May or 2nd May, can I get data of all people who applied for loan from my system? Can I map these set of responders with respect to the set of customers to whom I offered? Wherever there is a matching, I can say these are the responders of the campaign. Can I put a 1 across them? What will I do for the set of customers who are not part of that? I'll put 0. This is how I generate 1 and 0 information. This is how I generate 1 and 0 information for the first campaign. Now, once I have 1 and 0, I have all the historical attributes of this customer before I executed the campaign. Yeah. Those will become my variables, independent variables. And then I will try to establish a relation between these independent variables and the target. That is when in May I'm going to build the model. Assume by end of the May I have built the model, made a presentation to the client and showed them what is the efficiency of the model, what is the efficacy of the model, and the client likes it. Client says, okay, you have built the model. We would like to test the model. So June will be my first rollout. When I roll out it in June, I can take data till which time period? Till May. Because I can take the data till before the execution of campaign. In April, I took data till March. April was my prediction window. Now when I am rolling out a campaign for June, I don't know who is going to be responder in June, but I till May end I have got data, no? Why will I go till March only? Because latest information is more meaningful, right? Let me give example why latest is there. In March, the customer had 5 lakh of FD. But in April and May, because of some reason, he had to break the FD and he had to spend all the money. The May scenario is more relevant than March scenario, right? At that time he was rich, now he is poor from a balance point of view, right? So I'll take information till May, just before I can run the campaign. When I'm supposed to process it, as recent as information available, I'll take it, process, identify using the model who is likely to take the offer, who is not likely. Now the model is going to give me propensities. It cannot give me 1 and 0, because 1 and 0 will only come when the customer actually comes and take it. So relatively I'll say, based on propensity, who is more likely and who is less likely. Those who are more likely, I'll send them. Those who are less likely, I'll not send them. Yeah. And now when I execute it, the campaign, in June, I'll come to know actual 1 and 0. By aggregation, I can know what proportion of customers responded and what proportion I did not respond. I can then check with my segment-wise propensities. If the segment-wise propensities that I predicted and vis-a-vis what I actually saw, if they are in line, my model is working. I can keep using that model month on month. Yeah. So Parul, did you get an answer how I get ones and zeros?
Yeah.
Parul?
So the first thing that we have to do is to, create that target variable.
Yeah, for that you will require some pilot campaign.
Okay, okay, okay.
Yeah.
Okay. So for example, like in any continuous variable also, like for example, sales we have to predict, or let's say in the project that we are doing on the stock also. So in that case also we have to,
No, we'll
first
not go
define the
through
target
sales in that
variable
way,
and create a
but
target
we have to
variable
create the
first.
target. So somehow we have to create the target. Yeah. Okay. So let's move forward. Based upon such pilot campaign, the data is created. Once my data is created, I can now start building model. Before I start building model, I need to first understand each and every variables. A quick and easy way to understand each and every variable in R is basically run a summary function. Yeah. So when I run a summary function, it quickly gives me the information for each variable. So when I see customer ID, it says 111 and 1994. So I can see this is my identifier. Customer ID is my identifier. I can see target is 0 and 1. That is what I expect. Age is between 21 and 55, which is in a permissible range. Okay. Gender, female, male, others. There is a small data set which is of others, which means somewhere I need to club it into some segment because it's a very small base compared to male and female. Either I have to delete this or I have to combine in with some segment. Okay. Balance, I can see min balance is 0. Max is going up to 12 lakh 40. Yeah. Occupation, again there are missing categories here. In a model, missing cannot be there, which means null cannot be there. If I have null values, those records will be ignored in model development. I'm saying complete record will be ignored. Okay. So I'll have to remove them. So probably what I'll have to do is probably I'll have to put a word missing. The moment I put a word missing, it's not null. Or I have to put something. Yeah. Then number of credit transactions, I see that min is 0, max is 50, there is this range, okay. So long as number seems to be in a range, I'll say okay. Then there is a age bucket segment slabbing. Okay. Score minimum is 100, maximum is 99,999. It's okay. Holding period there is a missing, and then there are 1000 NAs. Again these are missing. So again I have to do some treatment for them. So first step, when you do summarization, you tend to see certain things you have to observe. What you have to observe is whether there is a unique identifier in your data. Second is the min-max range for continuous variables within permissible limits. Whether the mean, median values, what are the mean and medians for the continuous variables, because it gives you some idea about data. Okay. Are there missing values? In categorical variables, what are distinct categories? And which are the top categories? Okay. For example, when I see gender, I can see that almost 70-75% is dominated by male. And this is a minuscule category, so I need to do some merging of this with one of the categories. Okay. Occupation. Occupation, I can see this is a small segment, and these two are my biggest segments, professional and SAL. Yeah. So some amount of data understanding is what I'm gathering while I'm doing my summarization. So next step is a more detailed understanding of the data, continuous variables. I want to see outliers. I want to see whether there are outliers in data or not. When you want to see outliers in a data, you should see percentile distribution for continuous variables. So what I'm going to do is I'm going to run a quantile function in R to get percentile distribution. We make use of a quantile function. So I'll run this. Then I'll run this for age. Age is my another continuous variable. So I'll run that. Then I have to run it for holding period. Now again here I have just given 2-3 variables. Explicitly running for each variable one at a time will not take more time. What if you have 400-500 variables? Will you keep running this like that? Probably no. So a better and some easier way, I am making use of apply and sapply functionalities by which I can run this quantile for each and every record. I'm not going to explain the syntax because we are in analysis. In analysis, I'm going to talk more about interpretation of numbers. Okay. So is there a way by which I can run this for all the numbers, all continuous variables? Yes. So it has done for target, age, balance, number of credit transaction, holding period. Anyways, target I'm not bothered of. So I'll see for age. Parul, I'm not going to explain the syntax. When I see the age, so I can see that 21, 24, 26, 30, 38. So 38 is my median. Okay. 47, 52, 54, 55. So I don't see there is any outlier here. If I see the distribution for balance, what I can see is 575 something, 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 and then I come to this. P99 is 7,23,000, but P100 is 12,40,000. In one percentile, there is a jump of 5 lakh. Whereas from 0 to 99 percentile, the number went from 0 to 7,20,000 only. But from 99 to 100, the number has jumped by 5 lakh. So I can say that there is some outlier here. So I need to do this outlier treatment. For number of credit transaction, I can see, okay, from 0 to 49 and then 50. It's well in range. Score from 100, 108 to 999, and here it is 992 and 999. The numbers are very close to each other. These numbers are also very close to each other. So I can say there is no outliers. Holding period also there don't seems to be outliers. So I can see that there is some outliers in balance. So I need to do outlier treatment for balance. Typically, outlier treatment, how do we go about doing it? For continuous variables, we see the percentile distribution. If there is the outlier on the lower side, which is towards the 0, 1 percentile, what I am going to do is I am going to cap values at P1. At times you may want to cap values at P5 also. Okay, so I'll cap the values at P1 or P5. Yeah. If there are outliers on the higher side, typically I will cap value at P99, or if required I may cap even at P95 also. So outlier treatment, I'm again repeating the word outlier treatment. Don't confuse outlier treatment with missing value imputation. Outlier treatment means there are values which are out of range. And when the values are out of range, we cap value at, on the higher side we cap at P99. At times we may also do at P95. And on the lower side, which is on the floor side, we floor the values. We cap the lower side at P1. At times you may also want to cap it at P5. Okay, so that is called capping and flooring. That is called capping and flooring, which you use for outlier treatment. Yeah. Should we see the significance of outliers? Yes, we should also see significance of outliers. What she is saying is, should we try to find out reason why that outlier is there? Yes, we should try to find out the reason why outlier is there. I think so I gave one example of a retail transaction where I did analysis and we found there are certain customers who have 100, 200 retail grocery level transactions, who have 100, 200 grocery level transactions in a month. Okay. So when we did that analysis, we found that there are certain staff who used to create their own loyalty card, and when some customer would purchase and they did not have loyalty membership, they would swipe their own card to gain the loyalty points. So when doing a model, you may want to do these outlier understanding also, how these outliers are generated. There may be few cases, but even if you don't do the outlier treatment and go ahead and build the models, the model is not going to be impacted because you are capping them. You are capping the outlier values. But by doing these kind of things, what may happen is you may sometime avoid unwanted records coming into your analysis. Okay? And you will get better insight of your business. But otherwise, if you would go straight forward and do some capping at P1 and P99, if that is the range where there is a very small minuscule segment for which there is outlier values, your model will not be impacted. But yeah, if you are capping at P5 and P99, then there is a 5% segment in outlier. Probably you may be better off identifying why this much deviation is coming. Yeah.
So you're saying at 95, if it is there, then we should see.
We should try and understand the introspect the things better.
Okay, okay. And if like, so is it only above 95, right? Because normally...
No, see, typically if there is
the
a huge outlier coming, then there may be some reason why there is huge outlier. Okay. But
Mm-hmm.
typically, most of the time, if the data is rightly prepared and wrong cases are already handled by base filtering process, then the outliers typically we will identify by capping at P99 or P1, the problem will get resolved.
Okay.
Okay.
But there are some other methods also, no? Like we can remove also those outliers or probably delete those
Yes, outlier
observations.
treatment, either you delete them or you cap them.
But which is the preferred one? Like, I mean,
Capping. Capping is a preferred one rather than
okay.
deleting them.
And why?
That's what most of us we do because there are other attributes of that customer. Why would I want to lose out on those attributes? Because this is just one attribute on which
Mm,
he is outlier, right?
okay. Okay, okay.
Okay. So this is what we done. So I already explained this capping thing and flooring thing. Typically we floor and cap values at P1 and P99. So in our case, we see that there is an outlier in balance. So what I'm going to do is I'm going to do capping at P99. P99 is around 7,22,926.2252. Don't type the exact number. Just round it off. 7 lakh 22. Okay, I can make it 7 lakh 23. Even if you make it 7 lakh 20, it's okay. Okay. Don't think too much whether it should be 7 lakh 22 or whether it should be 7 lakh 22 926.22 or whether it should be 7 lakh 25. Don't think too much. Just go ahead, take a rounded number and do the capping. Yeah. Now when you are doing a capping, a best practice is if you are capping a particular variable and do not override the same variable. For example, I am capping here balance. What I'm saying is if balance is greater than 7,23,000, then the value should be 7,23,000. Else, which this basically this is will happen if it is this condition is true. If the condition is false, then keep the value as same. This will return some value, but if you see, I'm capturing that value in a new variable, which is named as bal underscore cap. Whenever you're doing any treatment of a variable, okay, create a new variable. Don't override the existing variable. Because if you override the existing variable, what may happen is, if you at a later stage feel that that step you executed wrongly, that variable is already corrupted. You have to go back from start to create your data frame, data set again. Yeah. So whenever you do that, you should do on and create a new variable, irrespective of how small the change is. Once you are in an analysis mode, don't think too much that if I create a new variable, it is going to occupy space. Yeah.
But in
So
the final model, we will not take these two, right?
once you have completely done that, you can then keep the final capped variable and go ahead and use it.
Okay, so delete the previous one.
When we are capping means one of my capping is balance, and there are other variables as well, like imputation and imputation. And somehow this balance might have been used in calculation of those values. So when you are capping the variable, isn't it required to have the new values for them as well, or
No, it's okay even if you just cap the main variable, it's okay.
Because the mean and median of the other variable may get impacted if you cap or floor the balance.
Yeah, mean will definitely get impacted the moment I do capping.
Of other variables also, I feel.
See, if the other variable is derived from this variable,
Yes.
then it will also get impacted. So what you can do is you cap this variable and then run the logic of creating other variable. In that case, the other variable will be completely right. Right? So what the question is, if I have got a attribute which is a derivation of some variables and one of the variables is the variable which is being capped, then simply that logic of creating the variable should be run after the capping step. Okay? Not before the capping step. Or probably once you have identified which variable to cap, you rerun that logic so that the variable is rightly created. Yeah? So this is on capping. So here let's run the capping syntax.
Actually, the article which we have shared, when we try to open it, it just says it's loaded into memory. It doesn't open the file. I think it's a workspace project.
By seeing the percentile distributions, we come to a conclusion that balance may be a outlier variable and it may require capping. As such, I'm doing the capping of balance. Okay. So this is a if-else syntax. If I just do summary of balance only, I can see now that the maximum is restricted to 7,23,000. Mean is 1,44,000. I can see quantile distribution again, but that's not required much. So this is first step, capping, flooring, identification of outliers. Yeah. Second important thing when building predictive models is missing value imputation. Here we saw that in this summary we saw that holding period has got missing values. Now there are multiple ways of imputing missing values. One of the way is, what I can do is, there are 1,000 observations where holding period is missing, but for the remaining 19,000 observations holding period is available. Probably I can say that holding period is a function of balance in the account and number of transactions. Assume I can make that statement that holding period is a function of balance in the account and number of credit transaction. And because holding period is a continuous number, I build a linear model. Holding period tilde balance plus age. We saw the linear model. I build a linear model. I'll get a linear equation. And I know balance is populated everywhere. Credit transaction is also populated. Keeping aside those 1,000 transactions, remaining 19,000, I can build a linear equation. I get a linear equation. Once I get a linear equation, for those 1,000 records, I know what is balance and what is credit transaction. Can I compute holding period? I can compute. And I can say it is to be capped between 0 and 30, 31 only. I can predict the values of holding period. So that is one way of imputing holding period. one way of imputing missing values. Second is, can I put this in one of the categories by which my entire model will not be impacted? So what I will do is, I'll impute the value of this category based upon what is the target rate in this segment and compare with other segments wherever the target rate of missing segment is matching with a corresponding segment where data is available. I'll put these missings in that category. Okay, that is called mean value imputation. That is mean value imputation. So likewise, some other categories, sometimes you may use surrogates. Sometimes there are surrogates also. For example, if say gender is missing, but I've got another variable which is title. Now you say gender male or female is not there, but for that record title is available, Mr., Mrs., Master, Miss. From title, can I say who is male and who is female? So I'm using some other available information and then putting the value. So there are various ways by which you can do a missing value imputation. Yeah. So here what I'm going to take a very simple one, simple technique, which is a mean value imputation. What I'm going to see, what is the response rate, target rate for the missing segment, and I'm going to check other segments within holding period categories where this response is matching. Okay, so let us run some codes. The way to go about doing is, based on holding period, I'm going to create deciles, and for each decile I'm going to see what is my response rate, and then I'm going to check what is the response rate for the missing category, and accordingly I'll put them in appropriate. Let's run the code. So here I've got a deciling function. We'll directly compile this function. I'll explain what this function is doing. This function splits the data into 10 buckets such that each bucket has 10% of the data. That is deciling. And what is a decile? A decile is 10% of the total population. And the process of splitting is called deciling. So I've written a function for creating deciles. Okay. First step, I have to compile the function. Without compiling, I cannot use the function. Yeah. After having compiled this, because my objective is to treat the holding period, so I'll do some aggregations based on holding period. So what I'm doing is I'm taking this data in a temporary data table, and on that I'm running deciling. I'm taking it in a temporary data frame. I'm not directly corrupting. I'm not going to work directly on the main data set to avoid any inadvertent changes. And then there's some logic which I have written where I'm doing aggregation, and basically at decile level I'm doing aggregation. What this decile would have done, let me just show you the table. View TMP. What this decile has done is, each record it has marked that whether it is in which decile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 deciles are created. Okay. So it is just marking that this record falls in which decile. Yeah. And then based upon this code, I am aggregating the data. We'll see the output, what aggregation has happened. Probably rather than showing it like that, I'll show in view. Okay, the
But can't we
aggregation.
like simply simply impute by mean or median? We have to take
No,
into account the target also.
no, we cannot directly impute the mean. I'll explain why you cannot directly take. What is the question being asked is, why can't I do mean of holding period, run this, is not NA. NA.rm equal to false. So what is being question is being asked is, why can't I take the mean and directly say all holding period where there is no information available, just put 15.19 or 15. That's not a right way. Why? I'll explain. So what I've done is, based on holding period, I've created 10 deciles and I've done some aggregations. And now I'm seeing for each of that, what is my success rate? Let us see that table. This is the table that I get. First decile, it says that minimum holding period in this decile is 0. Maximum holding period in this decile is 1. All the customers who are between 0 and 1 holding period are part of this decile. Okay? And the overall average for this is coming as 0.52. And how many customers are there? There are approximately 1,296 customers. Of that, 111 are responders. So what is the success rate here? 8.56%. Then I see the second decile, obviously, because till 1 is already here. So here holding period, min holding period is 2, max is 5, average is 3.5. What is the success rate here? 8.4. Third decile, 5 is already gone. So 6 to 8 is coming, 9 to 11. Automatically this is happening using the decile function. Okay. Based upon decile, it has said that 0 and 1 will be part of 1, 2 to 4 will be part of this and so forth. And then I've just simply aggregated. Now, what is the success rate in cases where holding period is not available? 3.5. Let us take one scenario. I'll say any customers whose holding period is not known to me, that customer's holding period is actually 0. Yeah, I'll make that statement. If the moment I make that statement, any customers whose holding period is not available, that customer's holding period is 0, what will happen? All of these cases will get become this. Okay, if they become part of this, let's see how what would be the scenario. Let me take this data in Excel. This is my data table. Yeah. If I say these were zeros, then they would have got combined with this decile. If they would have got combined with this decile, so let me create new one decile. And the range would be, the headers have moved. These are the headers. Yeah. So this is new one. So this decile, let me increase the font size also. Yeah. Okay. this would have become like this. How many customers would have been here? 1296 plus 1000. Number of responders would have become 111 plus 35. Number of non-responders, and the success rate here would have become 146 divided by 6.43, which is actually 8.56, would have gone down to 6.36, which means those who are actually in a holding period of 0 and 1, when I now build a model using holding period as a variable, it will tend to bring down their probability from 8.56 to 6.36, which is wrong. Because in that segment I see better response. Yeah. So clubbing this with 0 segment is a wrong. Now let us consider another scenario. I say that all of them who has got non-available information, actually they have very high holding period and they should be merged with the highest bucket. If I do that, so new 10, basically now what I am doing is I am now replicating this decile. I am now trying to create this decile. New 10 would have become addition of this and the success rate here would have now become they are actually at 1.55 percentage. 1.55 percentage response rate. 1.56, but now I am making them 2.14, which means unwantedly I would give them higher propensity in the model, which is again wrong. What was suggested, why don't we impute directly as a mean of the total, which is 15 in this case. 15 would have come here, okay, 4.27, right? So assume this 15 is at a boundary line of this and this. So typically this value, what is this range? This one is selected. So the 15, which is the segment, they would have slightly higher response rate compared to the overall average, because this 15 to 17 is a range, right? Assume that would be 4.38 has gone down to 4.27, so it would be virtually 4.3 something. If I would have merged them with this, they would bring down marginally the response rate of this category also. So the ideal way is to see what is the response rate of this missing segment and then check this missing segment in this entire range where it falls. So where will 3.5 comes? 3.5 will come somewhere here in this zone. Because 3.5 will come somewhere here, my value should be something based upon interpolation. So what I'll take is 15.98. Average holding period is 15.98. This corresponds to 4.27. 18.98 corresponds to 2.47. Yeah. I can have this equation, if you recollect, y2 minus y1 divided by x2 minus x1 is equal to y3 minus y1 divided by x3 minus x1. what is y and x? This is x, this is y, this is x1, this is x2, this is x3, this basically. This is y1, this is y2, this is y3. Y3 is available to me. Y3 is what? 3.5. Y3 is available to me. X3 is available? No. If I solve this equation, yeah, if I solve this equation, I can say what should be the X3 value. So this is way you can ideally go ahead and do interpolation, and then if I say what should be the value of missing value of holding period, and then for all the holding periods which are missing, I'll put that value. Yeah, I'm not going to solve this entire interpolation, but I'll just see 17, 18 something. This is 16 and this is 19. This is 16 and this is 19. So 4.27 and 2.47. So the value will be somewhere around 17 or 18 something. Okay, I'll now randomly take 17 or 18 and put that value here instead of doing the entire interpolation and solving it. But did you get the logic? This is how missing value imputation is to be done. The other way, I already mentioned that you can build a linear model. You build a linear model, holding period as a function of other variables that you have. You get an equation, use that equation, now predict the value of holding period. Only thing that you should remember when doing a missing value interpretation, when you are doing missing value imputation, you should know that once you have done, when it goes into production mode, when you use the production mode, in production environment also you will get missing data. When you get missing data, at that point, will you be able to impute the missing value using the logic that you used during development? If you can, then use that logic. If you cannot, then don't use. For example, some people have come to me and said, sir, can we use there's some package called mice. I don't know what that package, I have not used it. That package automatically do clustering and it will automatically do imputation of the missing value. My question always to them has been, if you can use that package, then find out using that package. Tomorrow you get one row of a customer and that row has got a missing value. Can you now impute what should be the missing value? Because end of day you have to score that customer also. If I now take using this logic and now I say all customers whose holding period is missing, I'll put the value say 17. Now once I take this model for deployment, if there is a customer whose holding period is not available, because I know in development I considered it as 17, here also I'll have to consider it as 17. So the logic is available. For example, if I would have done imputation in development using a linear equation where holding period is a function of number of transactions and balance, I'll have a linear model. I can use that linear model in development also. I have the logic. So whenever you do imputation, you should remember, can you reuse that logic in deployment stage? If you cannot, don't do that kind of imputation. If you can, go ahead and use that imputation logic. Yeah. What we'll do is quickly,
So here also,
we'll quickly take a break for 10 minutes. So coming back to the slide where we started the missing value imputation, we saw how to go about imputing a continuous variable. So multiple techniques are there. So imputation is the process of replacing missing data with substituted values. I'm just summarizing it. In R, missing values are indicated by NA. When you see data, you will see that there are NAs in mild font will come. There are various ways of doing imputation: mean imputation, using information from related observation, imputation based on logic, as I mentioned, gender and title, creating a missing category. If you feel that you are not able to impute, then create a separate missing category. One of the approach could have been, I put this number as, depending upon the trend, I'll put it some extreme number, -999 something. But because it's a continuous number, probably that strategy may not work proper. Or if I have to create a missing category, then the entire continuous variable, I'll have to convert it into slabs. I'll have to convert into slabs and then have missing as a separate slab bucket. Yeah. Now let us see. This is the logic of imputation. How now I have decided that I want to impute holding period. Based upon that, I want to impute holding period as say 18. Based on interpolation, say the number comes out 18. Okay, I need not be exact, very exact, 17.75. That is not required. Okay, so let us run the code. Here is the script. Again, if you see, I've created a new variable. Why? I don't want to corrupt my existing variable. So this is a script for creating the imputed variable. Now when I do summary of this, I see, okay, all values are populated and there is no missing. When I see that for the original variable there is missing. Yeah. So we have seen the missing value imputation for continuous variable. Let us now see how to go about imputing non-missing, non-continuous, that is categorical variables. In our case, occupation, we saw there is a category where it is blank. Yeah. So what I can do is occupation. First, let me see what is the trend of occupation with respect to target. Yeah. Let me do cross tab. I could have done actually this also, cross table function also, and let me cross table LR_df dollar target comma LR_df dollar occupation. I get this cross tabulation. So here, what is the first one is number of observation, and then row percentage and column percentage. Actually, I'm interested in column wise. So I'll see this number and I'll focus on this number. Okay. So occupation missing category, there are 4,432 zeros, 208 ones, overall 4,640 missing occupations. Of that, 4.5, this number, if you do the addition of this and this, 0.955 and 0.045, that is 100, 1. Okay, so I can see here 4.5% of the customers who have occupation missing are 1, and 95.5% of the customers having occupation missing are zeros. Likewise, I see here this number is 4% for professionals, here it is 2.7, here it is 8.9, and here it is 1.4. Now I want to impute it. There are multiple ways to go about doing it. To impute this, again what I can do is I can use some statistical techniques. Probably I can build a classification tree model, k nearest neighbor, those kind of things I can do, and then do imputation. Or if I can go very layman's approach, then what I'll see is this 4.5 percentage I'll compare with known categories. Let's see self-employed. This is 8.9 and this is 4.5. 8.9 is far off from 4.9, 4.5. So I cannot merge these two categories. 1.4 is too low, then 4.5 I cannot merge it. 2.7 is also low. This is closer to this number. So probably I can say missing, I can bundle it with professional, prof category. That is one approach. Second approach can be, I'll have this as missing word only. Rather than bundling them with anyone, I'll say there's a decent number of population which is 4640 and it's a categorical variable. Rather than putting it in separate categories, one of these 4 known categories, I'll create a new category saying missing. Okay, so I have decided here I'll do the imputation here by creating a new category missing. Yeah. it's a right way. There is nothing wrong and there is nothing right completely. See, you are not doing 100% accurate thing. Okay, you have to take one strategy and you have to go ahead. So here I have taken a strategy. Can we use mode? What do you mean by mode? Maximum occurring?
No, I'm saying for categorical variables, we usually also use mode also, right? I mean, like for continuous, we use median and
The mode is
mean.
frequency, right?
Mm.
But just seeing frequency will not. See, this is frequency.
Mm.
Matching it based on frequency will not be a right process. Assume this frequency 4640 is this number, and this number would have been for self-employed. Assume the number would have been 4645.
Mm.
Are you saying that based on frequency I should go ahead and merge them?
Mm-hmm.
Because if you would have do it based on frequency, this is 4.5 percentage and this is 8.9 percentage. And both the frequency are closer to each other. As a result, what will happen? The response rate of the merged entity will be between 4.5 and 8.9. That would be around 6.7, which will be injustice to this category, self-employed. What you have to see is what is the success rate of the categories, not the frequency. Absolute numbers are not important. Okay? So
Okay.
here what I'm going to do is I'm going to take an approach where I'm going to merge them based upon I'm going to take a call that I'll create a new missing category. I cannot keep NA. The reason is if I run the regression process and if there are NAs, the regression process will automatically delete them and I don't wish to delete. Yeah. So here
So the first approach which you told, that seeing which is the nearest,
you can build a model.
that also.
You can build a model.
Okay.
That is also an approach possible, that you take all these known categories, 4 categories, use a technique like classification tree technique, build a model. Classification tree will give some rules based on which you can say which of the customers should be professional and which should be salaried. Then apply those rules and put them missing in those one of those categories. Perfectly possible. How much complicated steps you want to do in imputation, it's all up to you. Yeah. So here our approach is very simple. I'm going to say And also for the reason, because one of the reason is because I want to focus on logistic regression. If I from logistic I move into a classification tree technique, then all of a sudden you will get confused. Yeah. So here I'll take a small approach saying that okay, these I'll classify as missing. Yeah.
Okay.
So the logic is simple. What I'm saying is now also before I run this if else code, I need to know what is the class. If the class of this column is factor, I cannot directly use a if else condition. If it is a character, then I can do it. Okay, so let me see what is the class of this column. If it is a factor, what I'll do is first I'll do a conversion of that. Okay, I'll do a conversion and then I'm writing a if else code. This is my logic. So if I'm saying that if occupation is equal to blank, then missing, else occupation, whatever is the value, and I'm storing it in a new value variable occupation imputed. Okay. Okay. Now let me see the distribution. All the missings are populated. Yeah.
The class you said is should be character.
See, if the class is a factor, assume the class is a factor. Let me show what will be the problem if the class is a factor. Here I have done this conversion. Let me run this again, ah.factor. Okay. Now it is a factor. Now let me run this logic. This is the kind of output we'll get. Yeah. To avoid this kind of a problem, I'm doing it as a character first. Now, I know by making it character, I'm occupying more memory space. I don't want to occupy more memory space. I'll again run the same step. After doing all this thing, I can run this. Sorry. I can go here and again make it factor, no? Done, right? Okay. So whenever you're doing working with a factor kind of a variable, factor type of column, writing these if else, you have to be very cautious. Yeah. Okay. We have done the imputation. So what we have seen is imputation for continuous variables and imputation for categorical variables. There are multiple approaches. Nothing is right and nothing is completely wrong. So long as you are taking a logical approach. So long as you are taking a logical approach to put appropriate values, it's right. If you are taking an illogical approach saying that I'll directly put all of them as 0 or all of them as maximum, it will lead to wrong outputs. Yeah. Now we have done imputation. Now the next question is, I've got many variables. Which of the variables are important? Are all variables important? Are all variables are not important? Or can I have some way by which I can relatively say this variable is more important than the other variable? There are multiple ways to find out which variable is important, relatively more important than others. One approach can be very simple approach. You run a logistic regression one variable at a time. That is, target versus gender, target versus age, target versus occupation, target versus balance. And when you run logistic regression, for each variable, it is going to give you a p-value. P-value is basically the significance. Now here the p-value is significance. How significant that variable is. A variable which is more significant is more stronger compared to the other variable. So you can take that approach. In industry, many of the organization make use of a concept which is called information value. In industry, most of the organizations are using a concept called information value. So I'll now explain this concept of information value to identify which variables are important and which are not. This is the syntax part of it. Rather than going into syntax, first let me explain the concept of how information value can be computed. So let me open one of my blogs. This was one of my first blogs. Information value is one of the most widely used technique in industry to find which variable is relatively more important or which variable has relatively higher predictive power than other. Okay, when we were working on this kind of thing, I could have keep changing this age, and then I could have got gender. I can see visually that okay, the trend across them is more or less same. Then I can change the variable and then say okay, number of credit transaction. Then I can say okay, here as my credit transactions are increasing, my response rate is increasing, all of those things. But I cannot say like number of credit transaction is a continuous variable, holding period is also a continuous variable, and here I see that a low holding period, high response, right? I cannot say holding period is better off than number of credit transaction or not. Both of them have got some trend, but which has got better trend? If I want to find out a way by which I can say which has got a better trend, there has to be some test. For that you can do a single variable logistic regression, you can use chi-square statistics, you can use information value, you can use Gini gain. There are many ways, but industry has now more or less most of the organization use information value. So I'm going to explain information value. Yeah. So this is the documentation. There is a formula. This is the formula to go ahead and compute information value. Let me not explain the formula way. Let me take a simple example. If I want to compute IV of a variable, and that IV has to compute with respect to target, because target is my Y. Any variable which influences that target more compared to others is relatively stronger variable. Okay, so I want to compute IV. Say age is my variable. Now the first step, if it is a continuous variable, the first step in information value calculation is we typically bucket it into 10 deciles. Okay, and then we convert that continuous into categorical variable. 10 slabs will be formed. So what I have done is I have got my age and now there is a target, and target has got good or bad, 1 or 0. So these are my buckets. Some buckets I have formed. Here probably because the data is not allowing 10 buckets, so 8 buckets have been formed. Okay, 8 buckets. These many goods are there and these many bads are there in each of these bucket. What percentage of good are in this decile? That is 200 divided by 1655. Okay, that many goods are in less than 21 age segment. What percentage of goods are in 21 to 25? It is 210 divided by 1655. Likewise, I am computing what percentage of bads are here in each decile. So I can see addition of all these numbers will be 100. Likewise, addition of all these numbers will be 100. Now the calculation for information value is, step 1, you compute difference of percentage good minus percentage bad in a given bucket. When I do that calculation, 12.1 minus 7.5, 4.6. Likewise, I have to do this calculation for each of these rows. That is the first step. Percentage target 1 minus percentage target 0, percentage good minus percentage bad. Yeah. The second thing is I have to take a log to the base e, natural log of percentage good divided by percentage bad. If this I would have written as percentage bad minus percentage good, this would have been percentage bad divided by percentage good. Okay. So here I have to take this log. Then I multiply this number with this number and the multiplicand will come here. Likewise, I have to compute multiplication for each of them and the corresponding numbers will keep coming here, and then I add all of these, and that number which I get is called information value of that variable. So IV for age would be 0.21. This calculation we will keep doing for all continuous and categorical variable. This is a calculation aspect I have explained. You probably you might not have understood is why percentage good minus percentage bad, why log of it, why multiplication, and why summation. Okay. Now let us try to understand this concept through some intuitive way. Someone have come up with this calculation, but let me try to explain this through some intuitive way. Assume this is your fulcrum and this is your pivot point. Okay. Now this pivot point, if I apply a force from this distance to rotate it, and I apply the same amount of force from this distance, if I apply the force from this distance, which one will be able to better rotate? So that is a function of distance and force. And we know that the lever action will get better leverage when the force is applied from a highest distance. Yeah? Agreed? Can I assume for the time being that this percentage good minus percentage bad, that I'm computing is the distance. And can I say that log, basically I'm saying how much of goods are concentrated in a given bucket as a ratio of bad. Can I say that is amplification, or can I say it is a force? If I assume that is a distance and that is a force, so there is the first component of this 4.6 and 48.2 will come here. The second component may come here. Third component may come here. Fourth may come here. Fifth may come here. Something like this. As a result of which there is a force into distance. In physics, that is moments, or basically a torque is generated. Yeah. A variable which generates maximum torque. Can I say that is the best variable? That is able to give me maximum rotation, right? So if something which gives me a maximum rotation, maximum torque, I'm saying that variable is the best variable. Now, only that variable will be able to give you a good torque if logically you think assume there is a variable by which all goods, 100% of goods are sitting here. Yeah, in the first decile. And all bads are sitting in another segment. That variable is giving the maximum separation between good and bad. So that variable itself will say, if I segment the entire data based on that, if one segment will 100% of goods and other will have 100% of bad. In that case, percentage good 100 minus 0, this will be maximum, and 0 minus 100, that will again be maximum. So distance is maximized. So the first objective is which variable gives me the maximum distance. And I know if I can apply a force at a highest distance, I get maximum torque. So logically, if you see, this equation makes sense. If you apply the physics concept, logically you see it makes sense. If it logically makes sense, go ahead and use the concept. My funda is very clear. If logically it makes sense to me, then I don't keep questioning why percentage good minus percentage bad, log of percentage good by percentage bad. It is making sense. I'll go ahead, use this concept. Now, people who have used it over time, what they have found is, if I can compute information value for each and every variable, and now if I see what is the IV, if the IV is less than 0.02, and then I use that variable in building a model, most of the time it will come insignificant and it will automatically get dropped off from the regression process. What they are saying is they have got insignificant predictive power. If the IV is between 0.02 and 0.1, that variable has got a weak predictive power. What it means is, probably if you build a model, there will be other variables which have strong predictive power. They will actually give you the maximum differentiation between good and bad, but a small incremental efficiency. These variables have the capability of giving that small token incremental efficiency also. So probably they may come in model. 0.1 to 0.3 are basically medium predictive power, which means they can contribute in the overall model. 0.3 to 0.5 are those variables which are very strong, which means they will define the model. They can define the model. If it is greater than 0.5, suspicious. The variable can be too good to be true, which means you have to introspect why that variable is becoming too strong. Let me give you an example where I have come across this case, 0.5, greater than 0.5. I was building a attrition model for telecom. Now again, as I said, the way we select is a cutoff, and then we see observation, then we see the behavior of customers in a prediction window, and based on the behavior in observation window we try to predict. So the way we modeled was, we said that Jan 31st is a cutoff. All behavioral attributes of the customer in 3 or 6 months before that Jan we will consider as behavioral variables. Feb will see whether they have used the services or not. If any customer did not use the service, we will say those customers have churned from our services, and those customers who have used it are non-churners. Those who have not used it are churners. We created a variable saying that what was his most recent usage of service with respect to 1st of Feb. So anyone who used on 31st Jan, his most recent usage was 1 day before. Anyone who used last on 30th of Jan, his most recent usage was 2 days back. If anyone used on 29th of Jan, it would be 3 days back. So we created a variable recency of usage. And when we predicted, when we saw the trend, let me show the kind of trend that came up. The kind of trend that would come up if you use this kind of thing, you will see that this is 1 and this is 31. And here is my churn rate. The kind of trend you will see that will be something like this. Those who have used services in most recent time period obviously will not churn. Those who did not use for the entire month of January, and then I am saying that I am trying to predict whether they have churned in February. Is it right? Or they have already churned in January? If they have not used the service the entire January, and I am now trying to predict whether they will churn in February, obviously if you have not used in January, they will not, most of them will not use in February also. My churn rate in that will be highest. What you are trying to do, you are trying to predict churners amount churned. You are trying to predict churners amount churned. Is that any prediction? Now if you try to get this variable, IV will be greater than 0.5. If you get this variable, I will definitely be greater than 0.5. What it says is, what you are trying to predict, that event has already happened. So what prediction you are doing? The moment you, now if you see, when you are doing modeling, these statistics, there are multiple ways the statistics will tell you that you are doing something wrong. Only thing is you have to now think what is the meaning, how to use that statistics. So here when you see this greater than 0.5, you have to ask yourself, am I predicting the event which has already happened? And when you introspect, you will most often see that the variable is saying that the event has already happened in past rather than what you are trying to predict as future. Okay, and this is one of the concept which is extensively used in industry when we try to find which variable is important and which variable is not important. Is the concept clear to everyone? Yeah? So what we are going to do is we are going to, in R, we directly have a package WOE, which is called weight of evidence. Okay, we'll directly use this package weight of evidence to predict to see IV of all variables. Do we use IV in scorecard model? See, we use this typically when we use modeling technique like logistic regression. If I will build a neural network model, probably I may use in neural network also. Because in neural network, I need to do some reduction of variables. So basically when I have got many dimensions, see, I've got 500, 600 dimensions. Currently we are working with 7, 8 variables only. But frankly, we will have 200, 400, 500 variables. Yes. And when you have so many variables, will all the variables be part of final model? No. I have to reduce the number of dimensions. When I have to reduce the number of dimensions, I have to do something to identify which variables are important, which are not important. And IV is one of the most important concepts used to identify variables which are important and which are not important. Yeah. We'll not get into PCA. We'll explain that later. So here I have already have this package installed. So I'll just load it. Just see whether you have the package installed or not. If you don't have, then probably you have to run this command, DevTools, and you may have to even run this command, or probably the command might be because there is a change recently. So the command might be, it will give a warning saying that that this old command is deprecated. So the new command might be something like this. If you run this command, it will say that it is deprecated and it would suggest that this should be used to installation. Just check it and do the installation. So both of these packages are there with me. What I'll do, I'll take this part of the code outside. I'll take this part of the code outside and run only that much, IV mult function. Sorry, there's some syntax wrong.